Let's take a closer look at a full stride, combining visuals from each graph to understand the movement better. Again, the dashed line is the current frame. We can navigate the graph by simply clicking on a trace. And here I just clicked on the start of the left foot contact. So I can double click this to create a node. That's when the contact starts. This valley or almost straight line, horizontal line, is where the foot maintains contact with the ground. And then right here is where that foot lifts up off the ground. So let's double click it too. So that's the tip of the foot. The darker blue line is the left heel. So this area right here is when the left heel is on the ground as well. So this is when the full contact starts. And right here is when the full contact ends and he starts to lift his heel off the ground as he starts the propulsion phase. You can also note the absorption phase because the center of mass reaches its lowest point. At that point right there, all the force is being exerted downwards, and that's where the bounce starts to happen. That also marks the mid stance. The propulsion phase is right after that, when the center of mass starts going up in slope again. So when the heel starts to lift off the ground, up until the toe off, which we've already marked. This area right here, where there's no feet in contact with the ground, will be our airtime, our double float, where both feet are in the air. Within the double float, we have the initial swing, and you can see how the left foot has been swinging back while the right foot is starting to touch the ground. Following the green line, but also the ankle and the heel trace, you can see that they reach a plateau right here and then encounter the mid swing and continue to the terminal swing. That includes the second double float and finishes up with a touchdown again. If we turn off the nose, we can see the center of mass fluctuations more pronounced. So you can see when all of the weight is being put on each foot by going to the valley in the center of mass for that step. And you can analyze form depending on that. In this runner, you can see it's pretty consistent. You could also choose to look at how high the knees go. So here's the right knee, the left knee in the next step, the right knee again, and then the left knee again. You can see that they're very, very regular. Same with the knees goes with the angular data. So we have the right knee completely flexed, the left knee completely flexed, the right knee completely flexed, the left knee again, and then the right knee again. You can see how well the runner is extending their knees as well. Here you have the left knee fully extended, the right knee almost fully extended, the left knee, and the right knee again. And you can go over these details for all different phases of the run.